Hey everyone, I just wanted to make another video for today just to further explain what we began yesterday, which was actually finding the probability of an event that was occurring. Just if there was any confusion, I want to clear some things up. So when we're determining the probability of an event occurring is we're determining like the likelihood that something is going to happen. Like, what are the chances that I'll pick a green marble out of a bag of 10 marbles? Well, what it comes down to is we really just got to count. Now, we have to be able to read the questions very carefully to determine what we have to count. So here I just have a simple 5-question example up here that we're going to run through. So it says, an experiment consists of randomly picking a square section from the board shown below. Okay, guys, so here's our board. I have a bunch of squares with different shapes. Some of the squares have triangles, and some of the squares have stars, and some of them are just blank. So how we want to start, and I highlighted this because it's very important. We want to always find the total possible outcomes first because we're going to represent the probability as a fraction, and the denominator of that fraction is always going to be your total possible outcomes. Okay, so our total possible outcomes just means, well, how many squares are in this board? Because we're going to pick one square each time. So we just have to determine, well, how many are there in total? What are the total possible outcomes? Well, let's see. I can pick this triangle, or I can pick this triangle, or this triangle, or this triangle, or this blank square, or this star, or this star, or this blank square, and so on and so forth. So each individual square is a possible outcome. So we're first going to determine the total. So we're simply going to count up all these squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So since there are 16 squares, that tells me that there are 16 possible outcomes. Okay, guys, so I'm actually just going to write that up here. There are 16 possible outcomes. So that tells me the denominator of my fractions are all going to be 16. Okay, guys, so always do that first. Determine your total possible outcomes by counting up all the possibilities that you have. Okay, now we're going to start to find individual probabilities. So number 1 says, find the probability of choosing a triangle. So just notation-wise, guys, how we would write this, instead of having to write, well, the probability of choosing a triangle is, that's a lot of words. And I tell you guys all the time, mathematicians, probably the laziest people on the planet. So we use this simple notation, which is capital P for probability, parentheses, and then inside the parentheses, we write what we're finding the probability of. So here we're just finding the probability of choosing a triangle. So I'm going to be super lazy and just write the word triangle. Close that set of parentheses and then draw an equal sign. That's it. And guys, if you don't do that, I'm not going to take off any points. It's just basic notation. I'm more concerned with, is your fraction going to be correct? All right, so probability of choosing a triangle. What that's asking us to determine is, well, how many possible ways are there for me to choose a triangle? Ladies and gents, all we have to do is count up how many triangle boxes we have. Well, we have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 triangle boxes, so that tells me that I have 8 possible chances to pull out a triangle. So the numerator of my fraction is, how many triangles are there? And my triangle was 8, so 8 goes in my numerator. I'm drawing a slash for my fraction bar. And then my denominator is, again, the total possible outcomes, which is 16. So the probability of choosing a triangle is 8/16. Now, guys, I know that this fraction looks a little different than what we're used to because we're used to writing them the numerator on top, draw the fraction bar, and the denominator on the bottom, which is absolutely fine. I just can't do that in this Google Doc. So we can also represent the fraction this way. All right, so let's try another one. Number 2 says, find the probability of choosing a star. So again, guys, probability notation, capital P, in parentheses, write star. Now we want to find the probability of choosing a star. So all that's asking me to determine is, well, how many chances do I have to pull out a star? How many stars do I have? We simply have to count. 1, 2, 3, 4. So I have 4 chances to pull out a star, so 4 goes in my numerator. Draw the slash for your fraction bar, and your denominator again is your total possible outcomes, which is 16. Okay, so the probability of choosing a star is 4/16. All right, number 3. Find the probability of choosing an empty square. Okay, well, an empty square just means a square that doesn't have a shape in it. So I'm going to write my probability notation, which is capital P, in parentheses, what I'm finding the probability of, which is an empty square. Okay, now again, I have to determine how many ways or how many chances do I have to pull out an empty square? Well, how many empty squares do I have? I have 1, 2, 3, 4. So I have 4 chances to pull out an empty square. So my numerator is 4. Draw your fraction bar or your slash, and your denominator remains 16. Okay. So you guys, we're just counting. We're just reading the question carefully on what we're finding the probability of, and then simply just counting how many of those we have. Okay, so number 4 says, find the probability of choosing a circle. Okay, well, probability of choosing a circle, notation, I'm going to write or type. All right, let's look at my board. Now, I don't know about you. I mean, I'm making this video pretty late, but I don't think I see any circles. So can I count how many circles I have? Well, I can't really count any because I don't have any. So the probability of choosing a circle is simply 0 because I do not have any circles. But I still have to write that 0/16. But if you just wrote 0, that's fine as well. Okay, guys, again, simply just counting. All right, number 5. Find the probability of not choosing a triangle. Okay, guys, little tricky. Not choosing a triangle, that means I can choose any square that does not have a triangle in it. So I can choose a star or I can choose an empty square. Okay, I just can't choose these triangles. I can choose any square other than those 8 triangle squares. So I'm simply going to count how many options I have. Again, I have my empty squares and my star square. So how many do I have in total? 1, 2, 3, 4, 5, 6, 7, 8. So I have a total of 8 possible squares without a triangle. So my numerator of not choosing a triangle, I'm just going to type in my notation, is 8 fraction bar, and my denominator remains 16. Okay, guys, so again, just read what I'm asking you to find the probability of very carefully, and then simply count what you have either in the picture, or if it's a word problem, you got to read carefully on what I'm telling you have, or how many of a certain item you have. Okay, guys, please, I know this is a brand new topic. You have not learned about probability in elementary school, so this is brand new, and I know it's kind of hard doing a brand new topic virtually like we are, but please reach out to me if you have any questions, and I, as always, will get back to you as soon as possible. Okay, guys, after you watch this video, you're simply just going to complete a simple Google form on simple probability. That's basically just like this. There's some pictures and questions, and then some word problems and questions. Okay, guys, but again, if you're going through that Google form and you have questions, please reach out to me and I'll get back to you immediately. All right, guys, good luck. I miss you all so much.